Hello again and welcome to a new video in which we will use the Unity's new input system to make our character move around and do awesome stuff. Before we begin, I will link down below the repository, the GitHub repository of the input system. It is still in preview. It's 0.2.8 right now, but it changes every day. So here, look, like the last change was 2 days ago. So it is I think it's very smart. Just come here every 3 days, look at the changes, look what happened, maybe even take part in discussions in the issues, so we will know what's going on and what's up to date. I will obviously try and make videos that will explain all of the new changes whenever they occur. Also, I've created a new repository, top-down RPG, and I will link this below as well. In this repository, you will be able to see all of the changes and all of the code that I've written. I've split it up into subfolders like E02 for the first video, and this video will be E02 and so forth. So, what did we do in the last video? In the last video, we made this cute koala bear here move around. Let's see. So, if I play the game, we will see that this cute koala just moves slowly to the right of the screen. But this is very cute and all, but it's not what we want. What we want is for him to move when we push various buttons on the keyboard. So that's what we're going to do today. We're going to use the new input system that Unity has developed for us. So let's do that. Before we start, you will need to install this new input system. In order to do this, because it's still in preview, it is not part of Unity just yet, and you will need to install it via the package manager. So we will need to click Window, Package Manager, go to Advanced, Show Preview Packages, and here you can search for input. So move the keyboard a bit. So alright, input system, you will need to install it. As you can see, the latest version as of now is 0.2.8. You can click on the View Changelog right here to see exactly what changed from each version. All right, so install it. After you've finished install it, you can go to the edit. You need to go to the edit, to the project settings down below. Here in the active input handling, in the player section, active input handling, change it to the input system preview. There is three options right now: input manager, which is the old system; input system preview, which is the new one; and both. If you are currently working on some kind of project that already uses the old input manager and you want to try out or start migrating to the new input system, then you can click on both. As this project is completely clean and it has no input logic in it at all, I will use just the input system preview. After you do that, it will ask you to restart Unity. Do that and we can start. So I've created a duplicate of the E01 and call it E02. We have a script mover here, which is completely empty. Let's look at the last mover class and see what we did there and why it's not good enough for us for our next logic. So, as you can see, in the old class mover, we just defined some kind of speed. We set it by the Unity editor, and every update we just moved it by plus. Is exactly plus speed +1 to the right on the x-axis. Then we just set the transforms position and updated, which made the koala move a bit. This is very nice and all, but it doesn't really give us what we want, and what we want is the koala to move according to us. So in order to do that, well, first of all, before we actually get to the logic for the input, let's think about actually what's going to move in our game. Well, a lot of things are going to move. The character obviously is going to move around. It's going to move around according to our input. And monsters, enemies, are going to move around according to, well, all kinds of stuff, like the player's position. Maybe they just patrol an area. Maybe maybe they just rest, or maybe they talk to each other or follow their leader. NPCs might just stand about selling stuff. Or maybe they just walk around in a predefined path, picking flowers or whatever. So a lot of stuff, a lot of creatures or NPCs or movers will be in the game, and each of them will move in a different way than our character. So having just one class called mover will strictly limit how we can actually go about doing that. So instead of that, we will just create a mover class, this mover class, and it will have some predefined logic, like very basic logic, a basic mover if you will, that will do the basic stuff. And then we will inherit from this mover, we will create let's say a character mover or an enemy mover or an NPC mover that will be more specific to our specific scenario. So let's start. What do we need from something that moves? Well, we will need the sprite renderer, right? Because we need to actually make some kind of changes to the sprite renderer. Every sprite, like our koala code right here, as a sprite renderer, and we will need to make some kind of adjustment to it while it moves. So let's define it. Let's define it as protected, because as I said, we will derive from our mover here, and we will need to access its component. So sprite renderer, let's call it sprite. Okay, what else do we need? Well, we can continue moving the sprite by changing the transform, just like we did in the first video, transform.position. But if we're using a game that changes with physics, well, the transform is not good enough, and we will need something that is called a rigid body. So let's say that we have a rigid body component. Rigid body 2D, because we are in a 2D game after all. Let's call it a rigid body. So, and it's also protected. Well, we will need a couple more stuff, but that's enough for a start. On awake, let's add the awake, and obviously enough, we will make this protected as well, because again, we will derive from it, and we will want to change and call it again from our subclasses. What should we do on the await? Well, we should get some, we will get the instance of the sprite and rigid body. So our sprite should equal to get component, or in this specific way, and I'll show you in a second why, get component in children, a sprite renderer, okay, and the rigid body will equal get component for rigid body, right? So you must have noticed that I've used get component in children here and get component here. So what's the difference between these two methods? Well, if I use the get component on a koala code where the mover will be, let's add it right now actually, mover, right? If we just use it here, then it will get component will look around here, all of this list. And so it will find a sprite renderer, it will find a transform, it will find, well, itself, a mover, but it won't find anything that is a child object of this one. And what we're going to actually do here is we're going to create a new object, and we will call it a player, and inside of it, we're going to use the sprite. Change the koala code to a sprite. Sprite. And the player itself will have a rigid body component. Right? So a sprite inside a player. Player has a rigid body component, and it will also have the mover. Right? The sprite shouldn't have it. So the player will have the mover. So if the mover, a script here, goes to get component, well, get component will look over here at this list. It will find a rigid body. But if we use get component for sprite renderer, well, there is no sprite renderer here, but there is a sprite renderer on a sprite, which is a child object of the player. So it will look here. So get component in children. Great. Next on, we will. Next on, now that we have these two objects, we will need to create a subclass that will do something with those. Okay, before we create a subclass, let's create the actual move function. So protected, let's say void, because we don't need to do anything. Move. Now, what does the move should do? Well, it should move us about. How did we move in the last lesson? we actually change the position of the transform. Well, this time we will use our rigid body. So we get to a rigid body and we'll change the velocity. The velocity is just a vector that defines the speed and direction, and in which we will, or more precisely, the rigid body will move. So if I put the velocity to equal, let's say up, which is 0, 1, 0, it will just move upwards along the y-axis. If I'll do it 1, 0, 0, it will move right along the right axis, the x-axis. So this is how we will change the actual direction of our koala. So what should it be? Well, it should be some kind of combination between a speed and direction. So we will need to get this, right? So let's just ask for speed and direction. So vector 2, direction, right? Well, great. So speed times direction times time dot delta a tile time dot delta. Great. Need this. Okay. Now, all right. This should be all right. So now that we have our very basic, sorry about that, basic behavior for our mover, we can go ahead and create a more specific mover in our station, character mover. Character mover. This is not. Me. All right. Our character mover will derive from our mover, and it does not need all of this because it has it from the mover class. Now that we actually have this, let's go ahead and use the Unity input system. So how are we going around to do that? Well, we need to create something new that is called an input actions. Controls, we call this controls, and let's open it up. Now in this window we will define all of the actions, all of the stuff our character can do. Let's first of all create a control schema. We'll call it default, and we will add 2 devices. So let's say a keyboard, because we will move around with the keyboard and we will mark it as required, and we will also add a mouse and mark it as required as well. Great. So we have now have a default schema. We will add an action map. Let's call it a player, because these are all of the actions that a player can do. For example, let's add an action to move, or to interact, or to attack, or to duck, or to roll. All of the actions that a player can do. All of the actions are mapped to the player, to the action map. So that's that. Now let's say we had an action that is interact or attack. Well, that would be a single button. Like, let's say we want to attack with our mouse, it will be just one mouse click will enable the attack action. But we want to move around. And moving around is not a single button, it's multiple buttons, 4 of them to be precise. So WASD or the arrow keys. So our single button won't do for us. So we will need to delete this, and we will need to add a 2D vector composite. This is just a very fancy way of saying 4 buttons, right? So we have an up, down, a left, and a right button. Now we will need to actually, in the property section of each binding, we will need to choose which path or which button should be assigned to which binding. So the up binding in our case will be the W. So W. The down one will be S, which is this one. The left will be A, and the right will be D. Great, that's that. Now, if you'll notice, you'll see that the move action has all kind of more specific properties like initial state check, continuous, and pass through. Also a type, like you can define that it's always a key, always an axis, always an analog, and so forth. I'll leave it in any for now because it really doesn't matter. but you can change it to whatever one you like. In a future video, I will explain more about those initial state, continuous, and pass-through. But as of now, you don't need this for this specific video. If you really want to know, you can go ahead and go into the input system repository, and they have the documentation here somewhere, and you can just look at it for yourself. But if you just wait a couple of, let's say a week or two, then you will see exactly what it does, as I will post a new video. Right, so now that we have this, we will need to generate a C# class that will represent the controls we just defined. So we will click on the controls, click generate C# class, and define a class name. Now, the defaults here are very good, and normally you wouldn't change them, but because I'm creating a video with multiple sections like O1, O2, O3, and so forth, I will change this to be specific for our needs. So assets / scripts / O2 / controls.cs. I'll hit apply, and if I'll come here and look, I will see that we have a control class. Now, this control class is very like full of all kind of definitions and properties, and you can see all of the name, see the name down, ID, pet, keyboard S, just everything we just defined in that controls definition file. So you really shouldn't care about this. It will be auto-generated every time you make some kind of change in the controls. All you need to know, and it's there. It's here to help you. So let's go back to our code. So on a character mover, all right, so the character mover, what is specific about how the character moves that is not implemented in the mover itself? Well, the character should move via input. So that's what we'll do. We will need to define some kind of input. Well, we just created the controls, right? So we will need a controls. We will say it's private because no one needs it, or at least for now, no one needs to derive from the character mover. So we'll have just private controls. On the awake, we will first of all need to call our base.awake because we want to call the mover awake, which takes make sure the sprite and rigid body are initialized. And then we will use controls equals new controls, and that's just about it. In the last version, like I think it was 0.2.6, you couldn't do this. You actually need to drag and drop the controls schema from the editor into the class, but now you can just create a new controls because everything is just bundled up inside of the controls class. So that's good. Really like that. If anyone from the team that actually works on the input system watches this, kudos, very good job. Nice doing. So on to the next. Now that we have the awake, we will actually need to create two more functions. The onEnable, in which we will enable controls.player.enable, and the onDisable, which we will, you guessed it, disable the control. And we do this just, well, to prevent any kind of weird behavior. If for some reason we disable the player, but the controls still work, and then the sprite will move, it will be very weird. Just create some kind of a bug. So we do this to prevent any kind of weird behavior. All right. So we have these two. We have a controller. Now we just need to actually define what to do in each action. So the controls actually gives us a very nice way of doing that. So let's see. Controls.player, because we have the player mapping, and then if we'll just click here, we will see that it has a move. This move is the one that we defined. So move, and then we will have all kind of stuff here, but what we care about is the performed action, and we can just add some kind of a function, or anonymous function, anonymous method that will do something. So let's just say debug.log, and I am moving, right? Just like so. And let's see. So we'll go back to Unity. We'll go to our player, and we'll remove this mover because We don't really need it. We need the character move. And we'll hit play, and hopefully it will work. Up. What happened? Well, our character just fell down into oblivion. Well, obviously not, because I forgot to turn it from a body type of dynamic to a kinematic. Well, because a rigid body works with the physics engine, you will need to either just tell it to be on a gravity scale of 0, so it wouldn't be affected by gravity. Yay, it just stays there. Or you can just say it's kinematic, which is preferred because we're not going to use any kind of linear drag or gravity scale or stuff like that in the game. So for now, I will turn off and say it's kinematic. So now that we run the game and we will look at the console, hopefully if I didn't do anything stupid. Oh, yep, I'm moving around. All right, so let's actually do something about this. Well, this is very nice because it does something every time I hit one of the move buttons. But what do I want to do if I'm stopped moving? I stopped moving completely now. Well, good for us, they actually added a move dot cancelled. Great, so let's do plus equals, again context, and let's say debug.log not moving anymore. Right, let's see how it works. All right, so if I press W and hold it, you see I'm moving, and the second I will let go, not moving anymore. So you see that the basic functionality is working. Now let's actually make our koala bear move around. So how should we do this? Well, let's create a method. Let's create a method, we'll call it onMove. So private void onMove, and we will get the context. The context was input context. Remember, let's have a look. It's a callback. Input action dot callback context. All right, what do we want to actually do here? Well, we want to call our move function from the mover, right? The mover has some kind of a move. Well, how should we get the actual data? Well, we need some kind of speed and we need kind of direction. So let's just define our speed vector. Well, we want the koala bear to move at the same speed while it goes vertically or horizontally. So let's just create some kind of vector here, private. Let's call it speed v, or vector should be 2. And we'll, for now at least, we will just make it a new vector, static vector. In a future video, we will change this to be a bit more, we'll show you how to actually make this update every time we change something in the editor, so we don't need to stop the game and change it and replay every time. It will be a short video in the next one. But for now, we will just say, let's say 20 on 20. So it will move 20 and 20 on the x-axis and the y-axis. All right, now we have a speed, but what about the actual movement? Well, luckily for us, the context has exactly what we need. Well, if you're familiar with the last or the old system, you actually just needed to listen to some kind of input from the user. Let's say when the keyboard is W, get the value. If it's 0, then the W button is pressed. If it's 1, it's not pressed, and that's pretty much it. Well, now because we defined the move action as a 2D axis, we can actually get a vector explicitly from the context. So we will just get a read value, and we will tell the context, give me the value as a vector 2. So I'll just say vector 2, and it will just give me a direction. And that's it. We don't need anything else. We have the direction. All right, so now we will call our move, and we need a speed, which we have, it's speed v, and the direction that we just got. And that's it. Let's try it. Click play. And of course, you need to actually change the performance from this anonymous function to the onMove. So now it should work. Let's click play. And as you can see, it moves around. It's very slow, but it moves around. Now, if I stop clicking anything, you can see that it just keeps going. You see the not moving anymore is fired, but it just keeps going. Well, this is because I didn't really cancel the movement, right? On the cancel, we still just log something. So we need to actually do something that will stop the movement. So let's create another function or another method, and we'll call it onStop. So onStop sounds good. Callback context. So how should we make it stop? Well, we can do it in a number of ways. I'm just going to use it using the same speed, but just give a direction of nowhere, like a zero direction. So if you're moving at speed of let's say 1000 miles per hour, but at no direction, well, you're just standing in place. So let's do that. Move at speed and at the vector 2 of 0, which is just the 0, 0, 0 vector. And you can actually see it if you go inside. Let's see. I really hope they can actually see it, but trust me, it's just a 0, 0, 0 vector. So, and we will change the on cancel to onStop. So, no need to call it. Save it. And if we, you know what, just for the sake of having some cool stuff, let's make it 100. Be a bit faster because it's really slow last time, right? Alright, so save it, compile, and run the game. And now if I actually start moving around, and if I just let go and it stopped, amazing, great. Well, this is all for this video. In the next video, it will be a very short video, but I will just show you how to extract the speed to the editor and actually make it update while in game, because it's kind of tricky to do it. Actually, you'll be surprised. You actually need to, it's not really tricky, but you will need to find some kind of method inside documentation. So after we'll do that, we will go ahead and start using animations, and we will start, well, if you noticed, this is a very nice movement, but it lacks something very crucial. That is, if I'm going right or left, the sprite still faces the same way, which doesn't really make a lot of sense. So we will learn how to flip the sprite according to our movement direction. We will learn how to animate our sprite if we have all kind of animations, which will be the point for us to leave this cute koala bear aside, because, well, unfortunately, don't really have any animations for it. But we will use a different kind of sprite, a very cool sprite, to do those animations. So yeah, that's pretty much everything. I'll see you around in the next video. Please subscribe and follow on Twitter if you like that kind of stuff, and you will get all of the updates for my game and for my future videos. See you around, and thanks you for watching.